The other thing that is involved here, I don't know if you remember, I said look at those little cracks between the tiles, the endothelia. The size of those cracks is about 260 angstroms. That's really tiny if you care. I mean, it doesn't, you know, I don't know how to give you an order of magnitude. It's really tiny. And there are some other factors that interfere. But in a healthy environment, the only way LDL, remember low density lipoprotein, bad cholesterol, you've heard it a million times, the only way it gets inside underneath this tile, underneath the endothelia, and causes damage, the only way it gets in there if it's tiny. Very tiny. And what you want's big fat ones so they bounce off like, you know, beach balls. So the size of your LDL particles is very critical, and what you eat determines your genetics and what you eat determine the diameter of your LDL particles. So in an otherwise healthy environment, LDL particle size is extremely important. What you eat affects that. Not taking Lipitor, Pravachol, etc. doesn't affect that. But there's another thing that affects LDL migration. Migration just means going from where it belongs to where it doesn't belong. They're illegal aliens. Okay, sorry. Anyway, the other setting in which they migrate in an unhealthy way is if the endothelia are otherwise damaged. Classic example is the endothelium is damaged when insulin is present. So in the presence of high insulin, the LDL migration through the endothelia doesn't depend on the cell gap. It just goes right through the cells itself. So you kind of make a double whammy. And that's why, now back up, I want to say something. I brought up statins. I mentioned Lipitor and Pravachol, HMA-CoA reductase. There are a bunch of different words, but if you're familiar with those drugs, one of the reasons they work, and they do, is if you don't have very many LDL particles and your cells are sick, the size doesn't matter. The fewer you have that leak through, the less damage that happens. Did I say that clearly? The reason why cholesterol-lowering drugs work is if your LDL is low, there's fewer to leak through to migrate. But in a healthy cellular environment, it does not matter what your LDL count is, as long as they're big fat ones in a healthy milieu. I want to be careful about that. Now, another thing that governs this damage and reparative process is what's called reverse cholesterol transport. Now, reverse cholesterol transport means goes out and picks it up from the arteries where it's done its good job, hopefully the proper job, pick it up, it's now kind of spent or broken or inappropriate, takes it back to the liver, dumps it in the stool. Now, reverse cholesterol transport, everybody associates that with the good cholesterol, or if you don't, you should. HDL is a reverse cholesterol transporter. It goes out, brings the bad stuff back, puts it in the liver, cleans it out. The other important part of reverse cholesterol transportation is these guys, which I told you up here cause all the problem. They are designed in the setting of proper immune function mediated through cytokines. These guys are there to help. They can't help, they do harm, they can't do reverse cholesterol transport if this immune system isn't functioning properly. Now that's a very important thought. Probably could have been put in a better way. Damage is inevitable, healing is optional. Okay? Believe me, it is. And the optional part is called aging, or a catastrophic heart attack. It didn't heal. That's what aging is failing to heal. We'll talk a little bit, and we're all going to die. I'm not trying to hold up the notion of immortality, but hey, let's enjoy it while we can, and let's make sure it's as long as possible, as long as we enjoy it. Well, we'll examine that. Anyway, damage is inevitable, healing is optional. Balance between damage and reparative processes. Now let me tell you a little bit about that, because that's going to get into some complicated things. Not as complicated as what we've already done. You've done the hard work, guys, okay? The balance is this. If you have an injury, you have to go in there and clean it up so that new stuff can be there. If a building is damaged, you got to tear it down and start over. So that's the balance between the tear it up, break it down, and the reparative side. The break it down side is called catabolism. The make it new and make it better side is called anabolism. Catabolism, anabolism. You've heard of these bodybuilder guys doing anabolic steroids. They're being anabolic. I want you to be anabolic. But I want you to become anabolic through a natural process. Go forth and be anabolic, okay? Now, and so but the point is if you're doing more damage than repair, you're going to get sick and get worse. If you're doing more repair than damage, you're going backwards on as the arrow of time flows rather than forward. So how can you manage that? Well, you got to understand one thing, and that'll get to this. And I've mentioned this particular number before, but it's meaningful. Let's suppose when you're born you weigh 10 pounds. Let's suppose when you're 10 you weigh 100 pounds. Let's suppose when you're 20 you weigh 200 pounds. When you went from 10 pounds to 100 pounds, a tenfold increase in 10 years, you were anabolic because you were making new stuff like crazy. Now, by the way, anabolic doesn't mean androgenic. Anabolic doesn't mean man. A lot of people confuse the word anabolic with androgenic. I don't know if you care about that distinction, but I want to clear it up. Being anabolic, actually estrogens are a very powerful anabolic steroid in a certain setting and in certain ways. Okay, so the question is, from 0 to 10, you are super anabolic. You are super high on growth hormone. From 10 to 20, you are anabolic through sex hormones and some growth hormone. From 20 to the grave, you're catabolic. It's downhill from there. Unless you do something about it. And aging is an imbalance of anabolism and catabolism. It is an imbalance in damage and repair. Okay? Now, there's a limit to this. I read a lot of some of the longevity literature, which I don't pay much attention to, but they keep worrying about the fact you only get to live to 120 if everything's perfect. Somehow it doesn't interest me. But the point is, I'd certainly like to live, longer and feel better while I'm doing it. So when I'm talking about this anabolic catabolic balancing process, I'm talking about how can I maximize, kind of the gift I was given, which is life, in as natural means as possible. So let me be clear, that's what I'm talking about. So anyway, how do we become, what does becoming anabolic mean? Just take anabolic steroids? It does not mean that, and don't do that. Well, at the formal level, anabolic means DNA activation, RNA recruitment, and protein expression. Well, that really means a lot to you, I'll bet. Although there probably are some biochemists here. And I know some physicians. So what that means is your genes turn on and make some new proteins. Because believe it or not, protein expression, making new protein, making new protein is what it means to repair stuff, is what it means to grow new stuff, what it means to make old stuff into better new stuff. Okay? That's what DNA activation, RNA recruitment, protein expression means. Got to get that. That's what's helping it. That's what's happening down there in that little cell. Right down there with an electron scanning microscope, okay? So, what control do we have over this? I mean, this is happening at the microscopic anatomic level. Turns out you've got powerful control over this. Wait a minute, how could I have any control over that? You told me I spent from 20 to the grave being catabolic. Well, the body doesn't just shut down at 20 like a glider that you turn the engine off on. It's not that. So it does have this capacity for anabolism, and it obviously has the capacity for catabolism. But what we want to do is maximize anabolism, minimize catabolism, okay? I hope that's clear.